Hello and welcome to week 9. I hope everyone is doing great. Are there any questions? Anything? You can ask questions anytime throughout the lecture, okay? So I will start lecture by reminder about upcoming test 2. Test 2 information is posted on the Brightspace this Friday, March 17th at 7 p.m. Okay. Covering Chapter 4, Chapter 5, and Chapter 6.1. Today I will cover course content, and then I will go test 2 review questions. The review questions is based on here, test 2, term test 2 on Brightspace. If you click here, quick instructions. Unfortunately, I don't see the questions now. So anyway, I have the question on my hand here. This is practice questions here. So quick practice questions. Okay, quick practice questions, and I will go over those questions. Okay. So that is the agenda for today. Cover Chapter 6, Session 3, Session 4, and then go Test 2, review questions. Any questions? Okay, I want to make sure the lecture is recorded, the message being recorded. Okay. Okay, you ready? All right. So let's dive in. Chapter 6.3 is about area. So I will directly dive into an example. Use this example to illustrate concepts and techniques. Right? In your written assignment 4, you have a couple of questions related to this example 1. So pay attention, how do I use techniques to solve the area problem? You'll do similar questions for your written assignment 4. Okay. Okay, so I try to adjust my screen so that I can monitor your questions in chart area. Okay. All right. So, example. Let f equal to x squared. Consider the region under graph of f on the interval 0 to 1. So what you are asked to do, this is the graph y equal to x squared. You are asked to calculate the area between 0 and 1. This is the question. Calculate the area between 0 and 1. Calculate the shaded area. To calculate this area, we can use estimate. We can estimate the area. Okay. So how do we roughly calculate this area? We can divide this area into 4 intervals. So we can say from 0 to, so first of all, this interval given, we call it is AB. So given interval AB. Okay. If you want to divide AB into 4 intervals, each interval we use delta x. It is just B minus A over 4. In this example, B is 1, A is 0. So the length of each interval of 1 over 4. So the first interval would be here. This is 1 over 4. And this point is 2 over 4. This point 3 over 4. And this is 4 over 4. It is 1. So we divide 0 and 1 into 4 intervals. Okay. So once you get those 4 intervals, and then these 4 intervals divide the shaded area into 4 areas. Did you see here? See 1, 2, 3, 4. If I add those 4 areas together, that is the area I'm asked to do. This is just estimation, not exact area. I pause for a moment to see if you have any questions. So once you decide you want to divide 4 intervals, then you need to calculate the midpoint of each interval. Midpoint for each interval. Oops. Midpoint for each interval. And how do you calculate midpoint for each interval? So maybe I will specify those 4 intervals. From this diagram, what are those 4 intervals? The 4 intervals refer to from 0 to 1 over 4. This is 1 interval. And then from 1 over 4 to 2 over 4. And then from 2 over 4 to 3 over 4. Last interval from 3 over 4 to 1. There are 4 intervals here. Now I want to calculate the midpoint for each interval. You just do the average. Do the average. So first midpoint, 0 plus 1 over 4 divided by 2. So midpoint is 1 over 8. The second midpoint is 1 over 4 plus 2 over 4 divided by 2. What do you get? 3 over 8. This is second midpoint. The third midpoint, 2 over 3 plus 3 over 4. No, 2. There is a typo here, sorry, 2 over 4, okay? So 5 over 8. Last midpoint, 3 over 4 plus 1 divided by 2. It is 7 over 8. Any questions to calculate the midpoint? And the graphical representation of the midpoint is here. This is midpoint 1, midpoint 2, midpoint 3, midpoint 4. Okay? And once you get those midpoints, calculate the function value at those midpoints. So what you need to calculate is, I will maybe write down here. Calculate F. We have 4 midpoints. The first midpoint is 1 over 8. So calculate F 1 over 8. Second midpoint 3 over 8. Then 5 over 8. And 7 over 8. Calculate the function value. Remember what is f? F equal to x squared. This is our f. So f 1/8 is 1/8 squared. Okay. 1/64. Next, f 3/8 is 3/8 squared. Keep on going. So 5/8 squared. 25/64. Last one, 7/8 squared. Any questions? Calculate the function value at midpoint. Okay. And then we have one more step. We found the estimate of the area. Last step, the area use this formula. It is delta x times f, actually f1 of, generally speaking, the first midpoint we say x1. The second midpoint we say x2. The third midpoint we call x3. We have 4 midpoints. Each time you use delta x times the midpoint. And what is delta x again? See here, definition, delta x equal to b/a/4. What is a and b? The original given interval, 0 is a, 1 is b. Okay, so now delta x in this example 1/4. 1/4. And then you just keep on going. Delta x is 1/4 times fx1. So this one is fx1. It is 1/64 plus 1/4 fx2. This one is fx2. 9/64 plus x3 is 25/64 plus 1/4 times x4. 49/64. So you need to figure out what is this number. Okay. So any questions? And the final of this answer.
Excuse me?
Yes, please.
I just have a quick question regarding to dividing up the area under R. Will it always be under 4 categories that we need to divide it up to, or will it be specified that we need to divide the area under R under specific other variables?
Usually the question will be given. For example, your written assignment 4, the question asks you divide the area in 2 intervals or divide the area into 4 intervals. This example is 4 intervals. Another question asks you to divide the area into 5 intervals, into 10 intervals. So it will be given.
Okay, thank you.
Okay. Thank you for asking. Any other questions? Okay, this example resembles the written assignment 4. You have question 14, write down the question number. Question 14, you have part A, part B, part C. Part A, divide 2 intervals. Part B, divide 5 intervals. Part C, divide into 10 intervals. Okay, that is your question 14 in written assignment 4. And then question 15 in your written assignment asks you to divide into 5 intervals. Okay, this is we use estimation. okay, to calculate the area. If you want to calculate exact area, we are going to deal using the GeoGebra. You type in this command. Okay. You type in rectangle, RECTANGLE, rectangle sum, opening bracket, type in the function, type in the interval, original interval is from 0 to 1, and then the last parameter, tell the computer, do you want to use midpoint, or use left point, or use right point? If you specify midpoint, you must type in 1/2. So typing this exactly, this command in GeoGebra, you'll get the answer. That answer will similar to our answer here, 21/64. Okay, you can try by yourself. So would the estimation of the area be more accurate if you use more intervals? Wow, that's a brilliant question. The answer is yes. If you use more intervals, the result would be more accurate. Okay, great. Thank you for your question. Any other questions? All right. Okay, let's move on. From this example, we are going to generalize the general concept to calculate the area, which is in the following slide. I actually combined many slides into one slide here, okay? So I did all of this already. Did all of this together. By the way, during you can use Excel to facilitate this calculation, this part here. Okay, so generally speaking, if you have function y equal to fx, remember last class, we introduced the antiderivative function. So if I ask you, what is the derivative of x cubed? Anyone? What is the derivative of x cubed?
3x squared.
Thank you. 3x squared. And then we use capital letter Fx represent x cubed. Okay. Small letter Fx represent 3x squared. So the relationship is capital letter Fx, if you take derivative, it is equal to small letter Fx. And we call this capital letter Fx has a name, antiderivative of f. So at capital Fx is antiderivative of fx. Okay, so that is the from last class. Graphically representation, if this is fx, this curve is fx, where is capital Fx? This area is capital Fx. This is the graphical relationship between small fx and the capital Fx. Okay, algebraic relationship is here. Capital Fx take derivative equal to small fx. Okay. Okay, so if we want to calculate the area, we want to calculate this area, we use the same technique. Okay, first of all, because we are talking general situation, so we do not say divide interval AB into 2 interval or 3 interval, 4 interval, 5 interval, generally speaking, n interval. Divide AB into n interval. N could be 2, 3, 4, 5, etc. Okay. And once you divide into n interval, each interval we call data x the length. Okay. It is B over A over n. And after that, you calculate the midpoint of each interval. You have n interval. The midpoint is x1, x2 until xn. Those are the midpoint. Once you get midpoint, the area is roughly, not exactly, is data x times fx1 plus data x times fx2 plus until data x times fxn. This is the area, generally speaking. Okay, this is roughly equal to. And how do you find exact area as one student observed? If this n goes to infinity, this n becomes bigger and bigger, the area is more close to the exact area. And this is the definition of this slide here. Okay, definition of definite interval. So this is the area, if n goes to infinity, this limit is the definite interval, that is the exact area. We use this symbol here. Integral from a to b, fx dx. Any questions? And what this fx has to do with, so this is this on one hand, on another hand, this one, so this, remember talked about relationship between capital Fx. If this is small fx, capital Fx is here, capital Fx. And this is point A, this is point B. So the definite integral from A to B, small letter fx, it is actually equal to capital letter Fx. Okay. It is actually capital letter FB minus capital letter FA. Those are the relationship between small f and capital F. Any questions? Okay. Now go back to our first example here. Remember, we are asked to do if fx equal to x squared. So this is fx, small letter fx equal to x squared. This is 0, this is 1, this is y, this is x. Okay. So the same, if you want to find the exact value of this area, you use definite integral. So use from 0 to 1, small letter fx dx. It is actually capital letter fx, vertical bar 0 to 1. This equal to capital letter f1 minus capital letter f0. But the question is, what is capital letter fx? Remember, this becomes what is calculate this integral from last class. Okay, so this result, it is actually 1/3 x cubed plus constant c. Okay, so this is And what is this? This is our fx. We found capital Fx. We found capital Fx. And then plug in this capital Fx, 1/3, x equal to 1, plus c. Okay, minus 1/3, 0 raised to power 3 plus c. C and c cancel out. So you just have 1/0 and 1. So any questions? All right. So we did this part. This is generally knowledge. So now we understand this graph. If small letter fx is this small letter fx, the area is the integral of small letter fx, definite integral from a to b, represent this area. Geometric interpretation of the definite integral is actually the area. We already did that. It is just the area under this curve. And sometimes if you have the curve below the x-axis, for example, this part, and what do? So all the area above the x-axis are the positive terms. If the rectangle below the x-axis, you have the negative term. By the way, there's a terminology, Riemann sum. It is actually, remember, data x, fxi, add them all. That is the Riemann sum. All right. So this graph represents if you have something above x-axis and something below x-axis. So if you calculate the area from A to B, it is the area of R1 here minus area of R2, because R2 itself is negative. You minus negative, you actually doing the plus. And then plus area R3. Any questions? Okay. So we did it. This is important formula. This is the fundamental theory of calculus. Fundamental theory of calculus. It is actually chapter 6, section 4. It is said f is a continuous function on interval AB. So definite integral AB equal to the antiderivative function capital FB minus capital FA. So the relationship between capital F and small f is here. F prime capital letter, capital function, if you take derivative, it is equal to small letter function fx. The graphical representation, this is a small letter fx, and this part is capital letter fx. Those are the relationship graphically. Okay. Okay, this is just a notation. Okay, this is just a notation. Okay, let's take a look at the example. Let R be the region under the graph fx equal to x on the interval 1 to 3. Use fundamental theorem of calculus to find this area R. And then verify your results by elementary method. Okay, so how do we do this? So the question asks you to calculate area. We use letter A represent area. And from interval 1 to 3, definite interval 1 to 3. And then the function is fx. Fx equal to x. It is given dx. So this is the very first step. Okay. Now find the antiderivative of x. This interval actually equal to, what is integral of x? Anyone from last class? What is this one? Remember last class, xn dx equal to 1 over n plus 1, xn plus 1 plus c. Okay. So this one equal to 1 over 2, x2, and then 1, 3. So first plug in 3, then plug in 1. So the result is 4. Okay. So we use fundamental theorem of calculus, calculated the area. Any questions? And now, how do you verify this number 4 is the final correct result? Okay, let's use the very basic. How do I calculate this area? Now I'm going to verify. I will divide this area in 2 parts. One, I draw a parallel line from this point, parallel line to x-axis. So this part is rectangle. This rectangle has height 1. This is 1, and have the width is 2. Okay, from here to here, it is 2. So the area of this rectangle is 1 times 2 equal to 2. This is on one hand. On another hand, I have this triangle. Okay, this triangle, I have the base is 2. I have the height is from 1 to 3, so height is also 2. So the area for triangle, remember the area, okay, base times height. 1 over 2 times base times height, that is the area for triangle. Base is 2, height is 2, the result is 2. This is area for triangle. So the rectangle area is 2, triangle area is 2, the total area is 4. Then I proved. Any questions? By the way, the midterm this Friday, you will have this kind of question for sure. Indefinite interval, 6.1, that is 6.1. you will have those questions, okay? Any questions? I pause for a moment. All right, so we did this and we verified this. We also did this. So this question, remember, asks you to calculate the area under x squared from 0 to 1. Okay, we did that. So found the area from 0 to 1. Okay. So found the antiderivative function. It is 1/3x cubed. And plug in 1, plug in 0 to get the result. And you need to practice more questions. I would strongly suggest go to textbook examples, do those questions. And then go to odd numbered questions because the textbook have answer. Okay. And make sure you also do the online homework. It helps a lot. All right. So next topic, evaluate definite integrals. Last class, if I give you this question, evaluate without the interval, number 3, evaluate 3x squared plus EX. This kind of question might be on the midterm this Friday. This from last class, chapter 6, section 1. Okay. So let's do the review last class. What is this? And to do this, you need two formulas. One, xn, the integral xn dn, it is 1/n plus 1, xn plus 1 plus c. The other formula is integral ex dx equal to ex plus c. You need those two formulas. Okay. So first, so this 3 you can move out. X squared, it is 1/3 x cubed plus c plus actually c1. Okay. And then ex, it is ex plus another c, e2. Constant plus constant is a new constant. You can simply combine C1, C2 into C. So the final result would be C. So this is from last class. And today's class is definite integral. We have this limit here, so 1 to 3. So usually we do not need this C. We just need this part. And then plug in x with 3 first. Plug in x with 3 first. Then plug in with x with 1. Plug in x with 1. So 1 raised to power 3. And this is the final result. Any questions? Any questions? Okay, now I want to, before I move to the new content, I want to review some questions for this part for midterm test. Okay, so I have my questions ready here. Test to review. You can get those questions on Brightspace on test 2 link from test 2. So this is actually in indefinite integrals. Okay, so let's do this one. Let me see. Okay, this one, yeah. Okay, so question A, we need fundamental formula. Xn dx equal to 1 over n plus 1 xn plus 1. So this becomes 1 over 3 x cubed plus 1 over 2 x squared. And this one is actually x because x derivative equal to 1. And do not forget plus c. This is indefinite interval. Any questions? Okay, question B. So this equal to 2 times 1 over 7 x raised to power 7 plus 2 times 1 over 4 x raised to power 4 plus c. Then simplify. It is that 2 over 7 x raised to power 7, 1 over 2 x raised to power 4 plus c. That's it. Let me see the question. Can you slow down? Thank you, Tim Xiu. Thank you so much. Yes, I will slow down a little bit. Okay. Questions? I will slow down. Thank you for your suggestion. Okay. Questions?
A question.
Okay, thank you.
Yeah, so for these integrals, it doesn't have like an A and B on it, so it's just that would be accepted as the final answer?
The final answer without A and B must have the plus C.
Okay, plus C at the end, those would be, okay.
Yeah, and we call this kind of integral indefinite integral, indefinite. Wow. If you have A and B, that is a definite integral. Definite integral. Without AB, indefinite integral.
All right, thank you.
Okay. Thank you for asking. And the next question, and this one we need fundamental formula, EX integral equal to EX plus C. And we need 1 over X integral, it is ln X absolute value plus C. Okay. So plugging this formula, we get EX plus 5 times ln X plus C. That's it. That's the final result. So you need to know this kind of question for test 2 purpose. Evaluate indefinite interval. If you have AB, that is today's content. That is a definite interval. All right. So, any questions? Can you go back to C, please? Thank you, so C, question C. Yeah, this is C. Thank you for asking. Okay. Any questions? Let me see. The test will only have indefinite interval. Thank you for your question. Yes, correct. The test will only have indefinite interval. Okay, shall we take a 10-minute break? After break, we continue. Do you want to do the review first or do the chapter 6 new content? Chapter 6 we covered actually half content. Another half we actually covered more than half of chapter 6 already. Because I did a little bit fast. I want to leave some time for the midterm review, because that is important, midterm review. How did you get the singular? How did you get the singular x in 10a? Thank you. Question 10a. How did you get the singular? Can you clarify your question, Cameron? What is mean by singular x in 10a?
The answer 10a, it says like 1/3 x cubed plus 1/2 x squared plus x. How did you get that x?
Oh, thank you, Cameron. Thank you. This x is 1 dx. This is x plus c. Why? Because, do you agree? 1 is the same as x raised to power 0. Anything raised to power 0 is 1, right?
Yes.
X raised to power 0 is 1. Then use this formula. N is 0. When n is 0, this equal to 1 over 0 plus 1 times x raised to power 0 plus 1 equal to 1 times x raised to power 1 plus c equal to x plus c. N is 0. N is 0.
Would you do that for any constant?
Sorry?
Would you do that for any constant?
For any constant? Oh, thank you. Yeah, if you do 2x, for example, so it is 2x plus c. If you do 3dx, thank you so much, 3x plus c. So if you do it is 20x, it is 20x plus c. Yes. Okay.
Thank you.
Thank you for asking. Another question. There is a suggestion. You want to do review first? Okay. So after break, we will do review. Then we continue our new content for chapter 6. I agree with you. Let me answer this question before we take break. Why does 5 over x tend to 5 ln x in, oh, okay. Question 10c. Thank you, Lian. So question C asks you, the fundamental question is, what is this? 5 is constant, we can move out to, okay? From last class, this is from last class, okay? This is ln x from last class. It is formula we did from last class. Okay. Review last class. Okay, guys, 10 minutes break. After break, we will do review. I will go slow, take as many times as possible you want, okay? And then if we have time, we continue the chapter 6. If we do not have time, next week after test 2, we make up for chapter 6, okay? So that is the plan, okay? So our test 2 is priority for this week. Okay, guys, come back at 7 o'clock. Okay, welcome back. So review time for midterm. After review, we continue the lesson, the content for week 9. Okay. So the review question is posted on Brightspace term test 2 review questions. So we go question by question. So we go question 1. Okay. Question 1. I try to go slow. Please ask questions. Please stop me at any time for any questions, okay? Try to adjust my computer so that I can also see your chart area. Okay. Right. Suppose a farm has a river on one side, so this is a river. And the farm wants to build 2 fences in sections above the river. So the farm wants to build 2 section fence. This is one section. This is another section. There will be one shared fence. This is a shared fence. There will be one shared fence between the 2 sections. And no fence along the river. No fence here along the river. The farm has 3,000 meters of fencing. Found the maximum area of the fenced sections. All right. So, any questions about what is given, what is asked? Given you have a 3,000 meter fence, you want to use this 3,000, build 2 sections. One section is here, the second section is here. No fence along the river. Okay, so how do you build so that you maximum the sections, the area, maximum the area? That is the question. Okay. Okay, so based on this graph, let's say this is X and this is Y. Okay, so you are given X plus Y plus X, because this is also X, equal to 3,000. Okay, this is given.
I have a question.
Yes.
So one of the online assignments was similar to this, but it had that there was a third X because of that that divide. Would that be 3X plus Y equals 3,000, or would that be 2X?
So you're right, yeah, because this is a shared.
Oh, okay.
Okay, let me see. You are right, actually. Should be, so all the material this plus this plus this plus this Y, so should be 3X.
Okay. Good.
Thank you.
No worries. Yeah, that was one of the questions from.
So X plus X plus X plus Y plus X plus Y equal to 3,000, right? So this is X plus X plus X plus this one, total fence 3,000. Okay. So given this, and what is the area maximum? The area is just X times Y. Do you agree? Area is X times Y. Any questions? Okay, so now let's simplify the given. So it is the same as 3x plus y equal to 3,000. Okay. From here, what is y? Y equal to 3,000 minus 3x, correct? Any questions so far? Okay, so now our objective to maximum the area. Area is x times y, and y is 3,000 minus 3x. So simplify this, you get negative 3x squared plus 3,000 times x. Usually we use put the ordered item in front of the lower degree item. Any questions? And the problem becomes what is found the maximum of this area. The problem is found maximum value of negative 3x squared plus 3,000x. Okay, so if we use fx equal to negative 3x squared plus 3,000, how do you find maximum? You take the derivative of this function, right? What is the derivative? You take the derivative and let the derivative equal to 0. So you solve for x. Any questions? And once you solve for x, plug in x equal to y, here you get y. 3 times x. Any questions? So our final answer, the farmer should put x is 500 and y is 1,500, so that the farmer can maximum the first section. Shall we move on next question? Question 2. Find the relative maxima and the minima of the function. So this kind of question, the very first step, you found the critical value. To find the critical value, you need to find the derivative of fx. What is the derivative of fx? Okay, so the fundamental derivative formula, xn derivative equal to n xn minus 1. So x cubed derivative equal to 3x squared minus 3 x squared derivative 2x minus 12. X derivative is 1. X take derivative, it is 1. Constant derivative equal to, oops, battery is low. Constant derivative equal to 0. Simplify this derivative. And if you let this derivative equal to 0, you get, simplify this, x squared minus x minus 2 equal to 0. Factor this out, x minus 2 times x plus 1 equal to 0. So 1x equal to 2, the other x equal to negative 1. So those are the critical values, critical numbers. Once you get these critical numbers, so what? This critical number divide the real number line in 3 parts. So one is 2, the other is, so this is number 2. This is, suppose this is the number 2, and then number negative 1. So these two numbers are critical numbers. The critical number divide the real number line in 3 parts, part 1, part 2, part 3. Okay. Now let's evaluate the sign of derivative in those 3 intervals. Let's take any number from here. So let's say take negative 2. If you take negative 2, plug in negative 2 into f prime. So f prime negative 2 equal to, so negative 2 squared minus negative 2. Actually, you need to plug in here. This is f prime x. But because you have, okay, doesn't matter. So 6 times negative 2 squared minus 6 negative 2 minus 12. You do not need to know exact number. You just need to know this is greater than 0 or smaller than 0. That's it. So obviously, this is greater than 0, this number. You don't care what is the number. You just need to know this is positive number or negative number. Okay, so the sign of derivative is positive, as long as it is smaller than negative 1. Those are positive. Okay. Okay, next, let's take a number from 0, 1, negative 0, 1 to 2. Take any number. So let's say take 0. So f prime 0 equal to 6, 0 squared minus 6 times 0 minus 12. And this number is smaller than 0. So the first derivative, sign between -1 to 2 is negative, 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 negative here. Okay. Lastly, let's take a number anywhere from here. Take any number, maybe take 3. So f prime 3, 6 times 3 square minus 6 times 3 minus 12. We just care if it is positive or negative number. Okay, this is a positive number. So f prime is positive, 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 positive. Okay, so after that, if f prime, if the derivative change from positive to negative, function f has relative maximum. Okay, so I will continue here. I don't have room. Maybe I will continue here. Continue here. There is a room here. Continue here. So I write down derivative change sign from positive to negative. That means function fx has relative maximum. Has relative maximum. Okay. At which point? At x equal to -1, because at negative equal to 1, the first derivative change from positive to negative. So -1 is the relative maximum. Okay. So what is the maximum? So you have to calculate f -1. Okay. So f -1. So what is f? You have to plug in original function to calculate maximum value. So plug in x equal to -1 to original function. -1 squared minus 12, -1, -4. Okay, so it is -2, -3, positive 12, -4, -5, -9. The final answer is 3. The maximum value is 3 at x equal to -1. Okay, so we found one maximum. The first derivative change sign from positive to negative. From positive to negative. Okay. Next, let's look at what happened at the point x equal to 2. At x equal to 2, derivative change from negative to positive. When you change from negative to positive, fx has a relative minimum. Okay? So I'll continue. F prime derivative change sign from negative to positive. So fx has a relative minimum at x equal to 2. Okay. So what is the minimum value? Calculate f2. Plug 2 into original function. So 2 times 2 raised to power 3 minus 3, 2 raised to power 2 minus 12 2 minus 4. Okay, 2 times 8 minus 3 times 4 minus 24 minus 4. So what is this result? This is negative 24. Okay, so the final conclusion, the relative maximum is 3 happened when x equal to -1. The relative minimum is negative 24 happened when x equal to 2. I pause for a moment to see if you have any questions, because this procedure is important. How do you find the relative maximum minimum? Step 1, find the critical value. How do you find critical value? Let derivative equal to 0. Those x are critical value. Step 2, determine the sign of derivative on the intervals decided by the critical numbers. Step 3, if derivative change sign from positive to negative, fx has relative maximum. If derivative change sign from negative to positive, fx has a relative minimum.
The question?
Yes, please.
So with the values we calculated for f prime of x and fx, they were based off of just -1 and 2, right?
Yeah. If I let derivative equal to 0, I got to x equal to 2, x equal to -1. Those two numbers divide the real number into 3 parts, 3 intervals.
Okay. All right. Sorry, I got a little confused with an earlier example. Thank you.
Yeah. Thank you for asking. Make sure when you go home, redo this question. Okay. To see if you can come up with the correct answer. Okay, another question. Where we have to given the answer as a point, or there is a relative maximum at it. Good question, Rutina. Depending on how the question is asked, if the question asks you, find the relative maximum and the minimum of the function, your correct answer should be this. The maximum value is number 3 when x equal to -1. The minimum value is -24 when x equal to 2. That is the correct, complete answer. Okay? You don't lose mark, okay, if you answer that way. Other questions? Okay. Next question, move on. Question 3. Question 3. Find the intervals where fx equal to x raised to power 5 is increasing or decreasing, and the intervals where fx is concave up or concave down. This number 3. So there are two questions here. Let's actually 4 questions. 1, found interval, it is increasing. 2, found interval, it is decreasing. 3, found interval concave up. 4, found interval concave down. 4 questions here. Okay, so let's do it. The first step, find the first derivative. Calculate the first derivative first. So it is 5x4. Okay. So after you found first derivative, let first derivative equal to 0. Solve for x. So obviously, this is quite easy. Okay. So once you have this x, this is a critical number. This critical number divide the real number line in 2 parts. One interval is here, another interval is here. And now decide the sign of derivative fx in this part first. So take any number here. For example, take -1. So what is derivative -1? It is 5 -1. You only care about it is positive or negative. So the derivative is positive here. The sign of the derivative. Next, take any number in this interval, maybe take 1, to find the derivative f1. So it is 5, 1. So it is also positive, positive, positive. Okay? And now we can answer the question. When it is increase, when derivative is greater than 0, fx is increasing. Okay? So we have the sign of derivative all positive. Okay? So our conclusion, fx increasing on all the real numbers, maybe from negative to positive, or you can say on R, doesn't matter. So this fx is always increasing, not decreasing. You cannot find fx decreasing. It is always increasing. Any questions? Okay. So we answered question 1, question 2. Not decreasing, only increasing. Where increasing? On the whole real number line. Next, we found the concave up, concave down. To find the concave up, concave down, we need a second derivative. Concave up, concave down, you must find the second derivative. So the second derivative is 5 times 4x cubed. Take the derivative of the first derivative. So you got 20x cubed. Once you found second derivative, let second derivative equal to 0. What you get? You get x equal to 0. Let the second derivative equal to 0. So once you have this 0, again, draw a straight line, represent the number line, real number line. And this 0, divide number line in 2 parts, 2 intervals. And now you determine the sign sign of second derivative. Okay. So take any number in this interval, say -1. So what is the second derivative at -1? It is equal to 20 -1 raised to cube. It is smaller than 0. So it is negative, 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 negative here. Then take any number on this interval. Let's say take number 1. The second derivative equal to 1, 20 times 1. This is positive. So positive, positive, positive. Okay. So after that, you can if the second derivative is smaller than 0, second derivative smaller than 0, concave down. If the second derivative greater than 0, second derivative greater than 0, concave up. So specifically, concave up happened at infinity to 0. Concave up happened in 0 to positive infinity. Any questions? So to answer this question, the question are you found intervals x raised to power q is increasing. The answer for increasing is negative infinity to positive infinity. There is no decreasing. Okay, the original function always increasing. And then found intervals concave up. Okay, concave up is from 0 to infinity. Concave down, negative infinity to 0. Those are the final answer. Question 3. Questions?
I'm sorry, can you go back to that for a second? I just missed one part.
Sure.
Thank you.
Thank you for asking.
Thank you.
Thank you. Okay, shall we move on question 4? Found interval where function is increasing or decreasing. An interval where is concave up or concave down. Exactly the same question, but use a different function. The procedure is exactly the same. Okay, procedure is exactly the same. So let's repeat ourselves. First, found the first derivative. So what is the derivative of fx? Remember, xn derivative equal to n xn minus 1. So in this situation, it is -1. So fx equal to x raised to power -1. That is fx. So given fx equal to x raised to power -1, it is the same as 1 over x. The reason I write down x raised to power -1, I want to use this formula, x raised to power n formula, okay? So x raised to power -1 derivative equal to -1 times x -1 -1. Directly use this formula. So equal to -x raised to power -2. Okay, and then -2, I move it here, +2. Found the critical numbers. What is the critical number? Critical numbers are those numbers either fourth derivative equal to 0 or fourth derivative or does not exist. I will use this symbol represent does not exist. Okay. So look at our fourth derivative here. The fourth derivative equal to -1 over x squared. Do you think this one equal to 0? No. This one is not equal to 0. Okay. So we cannot find f prime equal to 0. But can you find the derivative does not exist? Yes. If x equal to 0, if x equal to 0, the derivative does not exist. If x 0, derivative does not exist, that point is also called the critical point, critical number. Okay, and that point divide the real number in two parts. One is here, the other is here, into two intervals. Okay. And once you have two parts, you define the sign of a fourth derivative. So take a number, for example, -1. When x equal to -1, what is the sign of f prime? It is negative, okay? It is negative. Now, take any number in the second interval, for example, +1, plug in f prime function, you got still negative, negative, negative. So the first derivative is negative throughout the real number line. Okay. If f prime is negative, that means the function is decreasing. Okay. So the sign of this is the sign. So the function is decreasing here, decreasing here. Okay. The sign of that is negative. Because it is negative, fx is decreasing. When fourth derivative is negative, fx is decreasing. At where? Throughout the number line, from negative positive to positive negative, positive infinity. So the answer for intervals, this function is increasing. We do not have increasing for this function. Does not exist. Okay. We only have decreasing. Where? Where is function decreasing? From negative infinity to positive infinity. Okay. I pause for a moment to see if you have any questions.
Excuse me?
Yes.
So just to be clear, the answer is does not exist, right?
The answer for increasing does not exist.
Okay.
The answer for decreasing is from negative infinity to positive infinity.
Okay, that makes sense. Thank you.
Yeah, thank you, Logan, for your question. Other questions? Thank you, Emma, for your question. Thank you, Rudina, for answering the question. If we need to figure out the y points of the maximum where we, yeah, Rudina, you answered correct. We need to figure out the y points of maximum, minimum. Okay, that's great. Thank you for helping each other. Any other questions? Okay, we found increasing, decreasing. Next, we found concave up, concave down. To find concave up, concave down, concave up, concave down, we need to calculate the second derivative. The second derivative, take the derivative, the first derivative, we get this one. This is first derivative. Then derivative again. Take the derivative of the first derivative. The result is the second derivative. Okay, and then still use this formula. Xn derivative n xn minus 1. N equal to -1 here. This negative is original negative, so negative 2. Okay, is n times x, -2, -1. The second derivative equal to +2, x -3. Okay, and it is the same as 2 over x +3. Okay. Obviously, the second derivative does not exist at x equal to 0. So this x equal to 0 is the critical point, because what is the definition of the critical number? Either equal to 0 or this is second derivative. We need to find concave up, concave down. So we either found second derivative equal to 0 or second derivative does not equal to 0, does not exist. Okay, but the second derivative will never equal to 0. So we try to find what are the numbers make second derivative does not exist. We found that number x equal to 0. Okay, and once we identify this point divide the real number line into 2 intervals. One is from -infinity to 0. The other is from 0 to +infinity. And then we pick any point to decide the SIGN, the sign of second derivative. Let's say take -1. Take -1, figure out the second derivative. It is 2 over -1 raised to power 3. It is a negative number. When the second derivative is smaller than 0, is a negative number, concave down. Okay, concave down at what interval? From negative infinity to 0. At this interval, concave down. And now, determine the sign of second derivative. Take a point 1. So it is 2 over 1 raised to power 3. It is positive number. When second derivative is positive, concave up. Concave up happened at what interval? 0 to positive infinity. So this is question 4. Any questions? Any questions? All right, shall we take a 10-minute break? Come back at 8 o'clock. We continue question 5 with, okay? So break. Back. Okay, welcome back from break. Any questions before we continue? Okay, before break, we did question 4. Now let's move on question 5. Same question, different function. Found increasing, decreasing, concave up, concave down. Okay. Just want to adjust my computer so that I can also see your chart. Okay, so to find increasing, decreasing, first you found the first derivative. Okay, so it is 3x squared plus 3 over 2 times 2x. Simplify, it is 3x squared plus 3x. Let this equal to 0. You get x let me see. So let this equal to 0, you get so 3x squared plus x equal to 0. So x squared plus x equal to 0. X plus 1 equal to 0. That's right. Double check. Okay, so now we get x equal to 0 and x equal to -1. Any questions so far? So once you get these 2 points divide the real number in 3 intervals. 0, so 0, -1. So this is interval into 3 parts. And you need to design the sign of first derivative in these 3 intervals. Okay, so to determine the sign, you take any number from, for example, -2, this interval. So calculate first derivative at -2. Okay, so this is first derivative. So 3 -2 squared plus 3 times -2. You only care about it is positive or negative. So this is positive number. Okay. So the derivative here is positive, 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 positive. Why did the 3 go again? Thank you for your question, Leila. See, the first derivative equal to 3x squared plus 3x. first derivative equal to 3x squared plus 3x. To determine the sign, you could ignore 3, that's fine. We only care about first derivative is positive or negative. Number 3 does not affect positive. Oh, it is matters because, so it's better because first derivative equal to 3x squared plus 3x. Okay, so we need to evaluate. Okay. Any other questions? Okay. Next, we take any number from -1 to 0. Maybe you take -1/2. Okay, take -1/2. We want to design the first derivative at -1/2. We want to see it is positive number or negative. So -1/2 squared plus 3 -1/2. The result 3/4 minus 3/2. 3/2 is the same as 6/4. So this number is negative number. First derivative at x equal to -1/2 is negative number. So first derivative is negative in this interval. From -1 to 0, first derivative is negative. Okay. Next, let's take a number from 0 to infinity. Let's take number 1. First derivative at x equal to number 1 equal to 1 squared plus 3 times 1. This is positive number. So this is positive. Okay. Okay, now we have conclusion. Found the interval where this one is increasing. How do you know which increasing? If first derivative is positive, it is increasing. So there are two positive here. One is from negative infinity to -1. This point is -1. The other is 0 to positive infinity. At those intervals, the function is increasing. Two intervals, function is increasing. Because at those two intervals, first derivative is positive. Okay. Any questions? Okay. Now let's look at decreasing. Where the function is decreasing. The function is decreasing at from -1 to 0. -1 to 0. First derivative is negative. So decreasing from -1 to 0 is decreasing. -1 to 0 is decreasing. Okay. Okay, questions so far? Next, we solve for concave up, concave down. For concave up, concave down, we need a second derivative. We need a second derivative. Means take the derivative of first derivative. The second derivative is this, 6x plus 3. Let second derivative equal to 0, you get x equal to -1/2. Okay. And once you get x equal to -1/2, it divides the real number in two parts, -1/2. One is from negative to negative infinity to -1/2. The other is from -1/2 to positive infinity. Okay. So now let's check the sign. Okay. Of second derivative. Take -1. Let's check the sign. So 6, -1 plus 3, negative number. Okay. So when you have a second derivative, when you have second derivative negative, it is a concave down. Okay, where is concave down from negative infinity to -1/3? And here, concave down. Then we check the second derivative in this interval. Let's take a number, maybe 0 is here, okay? So 6 times 0 plus 3, positive number. When second derivative is positive, it is concave up, where it's from -1/2 to positive infinity, concave up. Okay, we found the solution for question 5. Concave up from negative infinity to -1/2. Concave down from -1/2 to positive infinity. If you graph this function in GeoGebra, you will get proof. You can double check concave up, concave down. Questions? Shall we move on? Question, is the term test still going to be 6 questions like you said last week? The number of questions is, I don't know. Last week, the 6th question is based on if the test is in person, but the department decided they want, because we have 3 sections, online section, daytime section, we are in evening section, they want those 3 sections to be consistent. So the department decided test 2 is online. So I don't know how many questions for test 2. Okay, sorry, Rudina. Other questions? Okay, so question 6. Found absolute maximum, absolute minimum for this function on interval -2 to +2. This is question 6. Okay, so the procedure is find the critical point, critical numbers, and what is the critical number? It is the first derivative equal to 0. Those numbers are critical number, or first derivative does not exist. So what is first derivative? Let's calculate. Is 2x plus 2. Okay. So let this first derivative equal to 0. We get x equal to -1. Okay, we get this x equal to -1. And the absolute maximum and the minimum, you just need to compute. Compute f, okay, function at each critical number. And also compute fa, fb. So what is a? A equal to -2, b equal to +2. Okay, and then find the maximum minimum. So specifically, we need to find out what is f -1, because -1 is the critical number. We also need to find out what is f -2. Why -2? Because -2 is the given interval. And then we need to find out f2. 2 is given interval. One is a, the other is b. So out of these three numbers, find maximum, that is the absolute maximum. Find minimum, that is absolute minimum. So let's find it. So what is f -1? Remember, this is f, not f prime. So plug in -1 in original function. So -1 squared plus 2 -1 plus 1 equal to 1 minus 2 plus 1 equal to 0. This is f -1. Then compute f -2. So -2 squared plus 2, -2 plus 1 is 4, minus 4 plus 1, it is 1. Okay. And then f2 is 2 squared plus 2 times 2 plus 1 equal to 4 plus 4 plus 1 equal to 9. So out of these three numbers, which one is the maximum? 9. So 9 is maximum. Which one is the minimum? 0 is the minimum. Where does the maximum happen? Maximum happens when x equal to 2. Where is the minimum happen? Minimum happens when x equal to -1. This is bracket, not questions? Question 7, same question, different function. Find absolute maximum and minimum. Okay, so let's find the first derivative first. 5x4. This is first derivative. Let the first derivative equal to 0. You get x equal to 0. Okay. So next, you need to compute what is f0, what is f -2, what is f2, because a equal to -2, b equal to 2. So let's calculate f0. You need to plug in 0 into original function. So 0 raised to power 5 equal to 1. X equal to -2 raised to power 5. So -32 plus 1, -31. And then f2, it is 2 raised to power 5 plus 1. 32 plus 1, 33. Okay, out of these three numbers, which one is the maximum number? 33 is the maximum number. Where 33 happened? When x equal to 2. Maximum number 33. Which one is the minimum? Negative 31. When x equal to negative 2. Questions for number 7? Questions? So shall we move on? Oops. Good. Question 8. Application question. In 1994, population is 70,000. In 1996, population is 71,000. The population formula is given by Q equal to Q0 E raised to power chi t. Found the value of chi. What is the t? T is the year. Okay. Usually t from 1 to whatever number. But it didn't say when t equal to 1, you can assume t equal to 1 when it is 1994. You can assume. Can you assume t equal to 1 when it is 1990? Yes. The answer will not be changed. The answer will be the same. Can you say t equal to 1 when it is 1960? The answer is yes. So why not choose the one simple and easy? So I'll choose the first one. Okay. So let's say t equal to 1 represent it is 1994. Okay. 1994 is 1. And then 1996, what is t? Year 1996? Anyone? If 1991?
T equals 3.
Excellent, thank you. Okay, so this is clarification for t. Okay, now plug in when t equal to 1. So population is what? 70,000. 70,000 equal to Q0 times E chi when t equal to 1. And when t equal to 3, population is 71,000. Chi times 3. I pause for a moment to see if you have any questions. Here you see two equations, two unknown. We don't know Q0, we don't know K, but we have two equations. We can solve for K, we can solve for Q0. Okay? Okay. So we call this is equation 1, equation A, not A, B. Maybe let's call this is equation 1. Maybe this is equation 1, this is equation 2. Let's say, why does Q0 not equal to 70,000? Thank you for your question. the question was why not Q0 equal to 70,000? Because Q0 is the constant. We do not know. It is said 70,000 is in year 1994. And the year 1994 population is based on this formula. The population for year 1994 is based on this formula. So we have to straight plug in the formula. Okay. Other questions? Okay, now we use equation 1 divided by equation 2. Left-hand side, you got 70,000 divided by 71,000. Right-hand side, you got Q0E, K, over Q0E. K times 3 is 3K. Okay? And the left-hand side, simplify, you got 70 over 71. 30 cancelled out. Right-hand side, Q0 cancelled out. You got EK over E3K. Okay? And then continue. 70 over 71, left-hand side. Right-hand side, remember when you have EM over EN, it is equal to EM minus N. Okay? And it is the same as EM over EN equal to 1 over EN minus M. Same thing. Okay, so now I want to use this format for right-hand side. So it is 1 over E, 3K minus K. 3K minus K is 2K. Okay, so right-hand side copy down. Left-hand side 1 over E, 2K. Okay. And then you use cross multiplication. If you have A over B equal to C over D, you have AD equal to BC. Use this. Okay. So you got 70 times E, 2K equal to 1 times 71. So solve for E2K equal to 71 over 70. Okay? And then remember 2 weeks ago when we studied logarithm function, exponential function? Okay, so this becomes 2K equal to ln 71 over 70. So what is ln 71 over 70? You can use Excel or regular calculator. I have Excel. I put it here. So what I want to calculate, oops. So I want to calculate ln. Here. What is ln 71 over 70? In Excel, type in ln bracket 71 over 70. So that is ln 0.01418. So this is 2K. And the K, you just divide this number by 2. This number divide 2, you get K. Thank you, Timothy, for providing the answer. That's it. You got 0.01. I missed 10. Thank you. Thank you. Thank you so much. I missed 10 here. 0.014. You are paying attention. Thank you again, Timothy. Try to adjust my computer so that I do not. Okay, we solved for K. Question A. Question B. What is the population in 2020? So if T equal to 1 when it is 1994, 1996 T equal to 3, keep on going, keep on going. What is T when it is 2020?
T is equal to 27.
Wow, correct. So you just use the year minus 1994 plus 1. That is the formula. Use 2020 minus 1994 plus 1. You get T. Okay. Great. So to answer the second question, what is the population? We also need to solve for Q0. Okay. So we continue to solve Q0. We solve for K, although the question does not ask you Q0, but you must solve Q0 in order to do question B. Okay. So once I got K, plug in K into equation 1 or equation 2, you can solve for 0. So I'm going to continue plug in K into either equation 1 or equation 2. You can solve for Q0. Okay. So let's say equation 1. K is 0.0070923. And then what is Q0? Q0, both sides divided by this number. So 7,000 divided by E raised to power 0.0070923. So what is Q0 Excel?
Wait, I have a question.
Sure.
So would that be for K? Would that still be times 27 because it's K of T?
We haven't solved for question B yet. We still.
Okay.
Thank you. We haven't solved for question B yet. This is we solve for Q0 now. Once we solve for Q0, we do question B.
Oh, okay. Yeah.
Okay. Yeah. Okay, we solve for Q0. So I'm going to use Excel to calculate this number. So equal to 70,000 divided by E. In Excel, use EXP. EXP is E. Raised to power 0.07. This is 0.07. So the result is this number.
Excuse me. What was the equation you put in there? I didn't. Oh, sorry. Never mind.
Thank you. Okay. So Q0 equal to this is Q0. Any questions? Okay, once you got this Q0, Do question B. Okay, do question B. What is the population in year 2020? Year 2020 means T equal to 27. Okay. So now plug in the population formula. Q equal to Q0 E K T. Q equal to Q0 E K T. Q0 is this number. E K. K is 0.00700923. T is 27 times this one. Okay. And equal Excel. So equal Q0, this is my Q0, times EXP. And then K, this is my K, times 27. No, this is should be A5. Press enter. You get so this is the final answer. Population in year 2020 is this amount. Question 8. Okay. Last question, we're done. Question 9. Solve equations. Solve equation. We did question 10, right? We did question 10. So question 9 is our last question. Okay. So the fourth one. So x obviously equal to ln 5. And then what is ln 5? Excel equal ln bracket 5 equal to 1.6094. Question B. E raised to power equal to E raised to power 2. So let the power part equal. And then move 2 to the left-hand side. 5 minus 2 equal to 3. Factor out x plus 3, x plus 1 equal to 0. So x equal to 3, negative 3, and negative 1. This is B. Question C. First, copy down left-hand side, then rewrite right-hand side to ln x raised to power 2. After that, 2x squared minus 1 equal to x squared. And move right-hand side to left-hand side. And then you have x, one is 1, the other is -1. But we cannot have negative number as a logarithm. So if you type in Excel, you see, if you type in ln -1, it will not give you the number because we need ln x, x is positive number. So this one is discussed. The final answer x equal to 1. Okay, any questions?
I have a question regarding question 8. Question 8b, to be more precise.
Sure. A to B, yes.
So whenever I plug in that calculation into my calculator, I get a different answer. It is 188,999.886 instead of 84,174.79.
Can you try it again? I'm pretty sure my answer is correct answer.
All right, I'll do it on Excel. Give me a second, sorry.
Yeah, please, yeah. Can I have confirmation from any other student you got the same number as I? I'm pretty sure I did several times.
I got that
pretty sure
number.
about this answer. Anyone log in? Okay.
Yep, I got that number.
Oh, thank you.
8417.
Thank you, Yin. Thank you.
I got that one.
Great. Thank you, Tim Siu. Yeah. All right. Okay. Let's conclude this lecture. We have a little bit content for chapter 6, session 4, but that is not on the test 2. So after test 2, we're at Monday. By the way, next Monday is in class, in person, but I still have the link open. The same link will be used for the rest of semester. If for whatever reason you cannot attend class in person, you can always use the same link to attend class online. Okay. So that's all for today. Any questions? Please email me. And please allow 2 business days to have your email answered.
Thank you. I'll see you next week.